Hi there, and welcome back to Triplicate and what is part 10 of our battery tester charger project. And this bit is probably going to be quite short, this video, because it was originally supposed to be on the end of the last video, but I was going away for a week, so I just put the last one out as it was. So this time last time we we created a charging scheme specially for nickel metal hydrides, which when it was got up to 1.5 volts per cell would wait till the voltage hadn't increased for an hour and call that charged. So we implemented that and it seemed to work. So we really just in the world of nickel metal hydrides have to have a go at multi-cell batteries. This is my elderly Black & Decker drill, and it's an 18 volt, so 15 cells. So we're going to have a go at this, and this is the charger for it. It just slides on the top like that, and you can see I've already modified it so I can connect other wires to it. But instead of that, I'm now going to put one of these on it, so it goes on a standard charging system, and also probably this is the wire to a wall wart, which is the original method of charging. So I'm probably going to put some kind of a connector on this. So I can still use it if I need to take the drill to the boat. I don't want to be carting the triplicate charger down. I just want to charge it up. And I have also in the background done a bit of work on the software, the firmware in the charger unit itself and the PC end. So the main one is I've updated the graph. So now we have a 0 axis in this dotted white line, so you can see where 0 is, and the nickel metal hydride charge detection, I've given an indication of that, which is what this is. So if it gets over 1.5 volts per cell, it starts a timer, and then if the voltage goes up, and this is the monitor voltage, not the run voltage, the charging voltage, it resets the timer, which it has done there and there and there, and it hasn't gone up after there, so the timer is counting down, as you can see, and gets to the end, and it goes into discharge mode. And that is a battery I found out of a bedside light, a AAA, and if we analyse that, it's an 1100 milliamp hour, so just under 700 is not just about good enough. Again, 2/3 quoted capacity I call minimum acceptable, but it does have a very low internal resistance for a AAA, so it would be good for a high current application. So that is that. So now we will get on and attach one of our charging plugs to the charger for the drill battery and see how that fares. And just quickly, forgot to mention, I have implemented auto voltage ranging. You can see here it just tells you what the range is. You don't get any option to set it now, because I got fed up with having to click the voltage range down from 30 whatever volts to 1.6 volts every time. The current doesn't really matter, we're not so worried about the current, but you can still set the current by manually. Okay, on with the soldering. Okay, here we are. You can see I've already been in this because I put these connectors on the top, and these are Torx. We have a Torx bit and a thingy to turn a Torx bit handle. So let's get the screws out. Alright, so it's got one resistor. It's got space for an LED on the board. And it's got 4 diodes, so I am guessing that this is AC. Okay, there you go. I've just reverse engineered the circuit. So it's, I guess they use the board for several different applications. So although the power supply claims to be DC, it's got a bridge rectifier and the inputs are labelled AC. Then it's just got a resistor to the battery to limit the current. Not sophisticated. And these sort of dashed in components, the resistor and the LED, aren't actually mounted on this. Though an LED would be useful to know when it's actually charging. And I am just going to connect the charging wires to the new plug across there. Easy peasy. Okay, there it is, it's back together. So I've connected the power charging and discharging wires to the board where the original wires down to the battery connectors go, and I've connected the sense wires there and there to as near to the battery as I can get them, so we get as accurately as possible reading. And I haven't in the end disconnected or put a connector on the mains charger, because as long as it's unplugged then all we're doing is putting voltage backwards across diodes, so no current will flow, so we'll be fine. So all I've got to do now is screw it all back together and we'll try it out. Okay, so here we are. Drill charger, wired super battery charger rig, and here is a battery. This is one of the original ones. It came with 2. I know the other one is Duff, and I suspect this one, and I bought another one when I was having problems with the originals. Anyway, we are going to see how it fares. So first thing I am going to do is, that is in off, so it's essentially monitoring the voltage. So let's see if we can detect 18 volts or whatever's across that battery. Right, I'll wait till the monitor picks that up, the PC program picks that up, and then I will bring you back. Okay, I just left this battery on for about 3 hours, and I did charge it up off the mains unit while I was checking things, and as a result the voltage has just dropped back while I've been out, about 3 hours. So 15.044, 15 volts and 44 millivolts it reckons. So should we just check that? And we want that one and that one. Open, you can, there we go, 14.99, near enough for us. So now we need to charge it up, so we better make a charging program on the computer to do that.
Okay, so we've got default here, measure capacity. Oh, let's set our battery first. I've got to put the number of cells in, which is 15, which gives me an 18 volt battery, and the capacity, well, the new one I got was 3000, and these old ones don't say on them, I'm pretty sure. So I'm going to put 2000 in. So we are going to stage 0 nickel metal hydride charge. Timeout, well, we usually put in 15 hours. Stage 1 discharge, end voltage 15 volts, discharge current 200 milliamps, okay. Stage 2 nickel metal hydride at 15 hours. Stage 3 trickle charge, wherever it is, at 20 for 10 hours. Stage 4 monitor, okay. And we're going to save this as Black Decker old. I know what it is. And it's my battery. There we go. So we need to send that to the charger and hit run. So that is trying to charge. However, okay, but unfortunately we think we're charging, we've got no current and the voltage is really dying, and that's because our power supply here, which is powering the charger, is only putting out 12 volts, and we need up to about, I guess, 25-30 volts. So we have our charging supply connected here, which we will turn on, and that's only set to 9 volts, so we're gonna bring that up. So let's just wind this up all the way, and it's charging at about 200 milliamps, and I've just wound that all the way up. It's about 30 volts. So let us now wait for another reading and see. Yeah, it's gone into error mode somehow. Okay, so I have identified the error problem. Error light works, excellent. The fact that it will not measure a charging volt bigger than about 26.5 volts, so that is on 26.5 volts. So if I turn that up, there, so that's 27.2, it gives out an error code. So okay, we've been running, getting on towards an hour, and it's charging up. So we just leave it running now, and I will bring you back when it gets to the end of its cycle, or something else interesting happens, or it burns the house down or something, which usually takes the best part of a day. That's running through a charge, discharge, recharge cycle. Burning the house down probably takes a bit less than that. So I am going to go and do something different for now, and you will, in the blink of an eye, know the outcome of this attempt to measure the capacity of this drill battery. Okay, so what's going on here? The highest voltage it's registered around here was about 22 volts, which is about 1.46, 1.47 volts a cell, so it never kicks into the voltage sense. And since then the voltage has been dropping gradually. So let's have a look. It does not say anywhere on this battery what technology it uses, but if we look there it says don't throw it in the bin because it's got cadmium in it. So I am guessing it is actually a nickel cadmium, this battery. It's that old. I know the new one I got was a nickel metal hydride. And I vaguely recall that the manual said, because there's no indication of what it's doing on here, and in fact the charging circuit is a resistor, and just a resistor anyway, it did say when it starts feeling warm it's fully charged, and that just feels noticeably warm. So shall we call this one charged and manually move on to the discharge cycle? Skip! There goes the relay going click, and I'll tell you the LED's on, yellow LED's on. You can take my word for it. Right, we'll let that discharge and I shall bring you back when it's discharged and we know how much charge it's been holding. Okay, it's discharging and it's looking for 1 volt a cell at the end, so that's 15 volts, 15,000 on the VMON, and it's still at 17 and just under 17.5 volts, so we've got a way to go. But what's happening here? Well, there are, whatever we say, 15 cells in series, and at this point 1 cell has gone dead, so there is at least 1 dead cell in this battery, or 1 not up to spec cell. So onward and upward, we'll see what happens when it reaches the end and is fully discharged. Okie dokie. Okay, so here we are, we're done, and my nickel metal hydride end of charging detection didn't work again, and it's the same pattern, you know, reverse delta V. So I am going to need to somehow adapt this to work with nickel cadmiums. It's the first nickel cadmium I've tried on it because I don't have very many. All my single batteries are nickel metal hydride. So now we are going to try this one, which, right way of saying read it, definitely is nickel metal hydride because it says on it. This was the new one I bought to replace this one, which was not brilliant, and the other one, which is duff. We'll try the other one at some point. So that goes on there, and I'm going to, although I set up my charging scheme for 2000 milliamp hours. Right, here we are. So we will have Black & Decker old again, even though the new one I know is 3000, not 2000. So we will send that to the battery. And we will run. Okay, so that's charging up, and I will update you when I have something to update you with. Okay, this has been running for a while, about 7 hours, and interesting. We can see here it's topped out at about 1.56 volts per cell. No, it's topped out at 21.56 volts, which is about 1.43 volts a cell, and this is a definite nickel metal hydride, so I definitely fancy this something to do with temperature going on here, because of course the cells are wrapped in a plastic box here, so the heat will escape from them so much more slowly. And I haven't turned the camera on. Yes, that battery is definitely warm to the touch. So I am going to call that charged and skip on to the discharge mode, and we'll see what happens to that in a few hours. Okay, so this is my known good 18 volt nickel metal hydride drill battery, and it's charged up. And two things to know. Yep, that one has problems with cells that die before the others, run out of charge before the others, and both times charging it did this reverse delta V bit and didn't get up to 1.5 volts a cell. So I am going to review my end of charge detection. Can I pull the voltage down, and will it just possibly ever decide it's finished charging when it hasn't finished charging? And I have left my 12 volt nickel cadmium drill battery and another known Duff 18 volt battery, so I will update the software and we'll use those as a test. Oh, and we forgot to actually see how it's performed, so we will analyse. So it's saying 2004 for the capacity, which is pretty good. On a quoted 3000, I'll take that. And internal resistance 0.9, and remember there's 15 cells in series, so this is calculator 0.9 divided by 15. Yeah, I know I should be able to do this in my head. 0.06 of an ohm, so these things are quite low resistance. Okie dokie, onward and upward. Okay, and this is the good, well, the new drill battery plotted out on a spreadsheet so we can get a better idea of the voltages involved. And if we look here, it doesn't get to 1.44 volts per cell, this is. So waiting for it to get up to 1.5 before we start looking for it to top out is not going to happen. So with that in mind, I have changed the software. So in the nickel metal hydride charge, we can set an end voltage dependent on the battery, because I think depending on the battery the end voltage differs depending on the construction of the battery, I guess. So I've done that, and this is just a AAA battery, so I have set that to 1.5, and as you can see that is working nicely. Okay, so I have updated the battery measure capacity definition for these drill batteries, and I've set the end voltage to 1.35, which it should get up to, okay, which is there, which is up the hill on both. So okay, so now we're going to test. This is one of the original batteries for the Black & Decker, and it's the Duff one, which is why it's got tape over the contacts so I don't try and use it or charge it, but we will see what it does. Okay, so I ran it for, so that's about 10 hours, and it had got up to about 18 volts with 2 jumps. What are these jumps? Don't know. Cells kicking in and starting to recover, or cells just falling over and dying. And then I went to bed and turned it off because I didn't trust the thing running overnight. I just don't trust it to be any good at all. So I should put it on now and leave it running again, and we'll see what happens. And the reason it's on a spreadsheet, not on the nice display, is Oopsie daisy, there's some bug crept into the loading of logs, which I can't be doing the fixing right at the moment. So put it back on to charge and let's see what happens. Oh dear, oh dear, oh dear. So yesterday it charged, well, it took charge for about 10 hours yesterday without appearing to be charging up. Today, all in a few minutes, it suddenly shot up to the voltage corresponding to 1.6 volts a cell, in which case it says it definitely must be charged. Who knows? And started discharging, and discharged for a very short time. Down to here, died, and then started charging again for, well, 5 minutes. The voltage went straight back up to 1.6 volts and it sat up there on trickle charge, and here it's just died down again. So I don't know what's happening with that battery, but it's not what's supposed to be happening. So that one's a definite duffer. So here is the battery out of my other, it's only Clark, which is Machine Mart's own brand, very cheapo drill, which is 14.4 volt nickel cadmium, it says there. So we're going to have a look at this one. This is the charging thing, which is a part which I'd already added these two sets of wires to, so I just put those into one of our plugs for our charger. So without further ado, as they say, we will put this back together, stick it on the battery and see if we can charge it up. Now this battery works, it runs, but it has had issues. It had an internal short and started emitting smoke at one point, so I've had it apart, and it's broken there anyway. So I've had it apart and had to sort that out, so we shall see how it fares. Okay, so there she is, plugged in, connected up and ready to rock. So let's send some settings down and start it going. Okay, I don't know what the capacity of it is, so I've set it to 1500 milliamp hours, and we shall find out when we measure it. Apart from that, I'm assuming it's the same as the Black & Decker ones, and well, won't go up to 1.5, so I've set the end voltage at 1.35, at which it starts the timeout. So let us send that down and fire it up and see what happens. Okay, so here we have this is run number 4 on our Clark drill battery. First 2 runs I had a bit of a problem. I got the battery definition, it was modified from the 18 volt Black & Decker one, and I'd set the end voltage on discharge to 15 volts, so it just thought it immediately finished. And the third one, some horrible software bug crept in and I couldn't get the data out of it. But here's the fourth one, and here's the analysis. So it's 1126 milliamp hours, and looked at the data sheet. I think it's supposed to be 2000, so it's not very good, but the drill is obsolete and nobody's making a replacement battery, so this is what we're going with. And got some funny results out of the 3 runs I did do, which I've put into a spreadsheet. So the first run charged up nicely with the reverse delta V, and then here discharged to 1.5 volts and went back into charge because of the reason I just mentioned. And here it was up at goodness knows what volts and quite noisy. So was there a bad connection here? As I say, it did have smoke coming out of it at one point, so there may be a cell that's very suspect. And this is the run we've just looked at, again with a nice reverse delta V here, but at a different voltage to here. So what's going on here, I don't know. So what I propose to do when charging this battery is discharge it, which is good for nickel cadmium ones because they have a memory effect, and then charge it for 9-10 hours and call that charged. And when it stops working, don't know what I'm going to do. Hate to throw the drill away because all the motor and stuff's fine. Anyway, that's it for the Clark drill battery.
Right, and that's about it for this video, which was originally just going to be a quick catch-up and has turned into quite a long video on multi-cell batteries, specifically nickel metal hydride and nickel cadmium drill batteries from old drills, but hopefully it's been quite interesting. So it's not the last, I think, I'm going to have to say on batteries. I might take a look at lithium ion, and there's my old battery charger, which I was going to have a look into that and see what commercial battery chargers do by way of charging schemes. But that will be sometime in the future. So for now, it is goodbye from Triplicate.
Goodbye.